In this video, I'm going to change gears a little bit and talk about some leak coding that I've been doing recently. I've been thinking about how to convert recursive solutions that I do kind of automatically into queue-based solutions because, well, it's a different thing and I kind of wanted to learn that paradigm. Also, they test easier. So if you're testing by hand, a queue is a lot easier to not go insane with. So I'm going to show this problem here, which is a permutation generator, problem number 46 on LeetCode. And here is my working solution. It's pretty good. Runtime complexity is we're running n loops through times the number of permutations, which is n factorial. So it's n times n factorial is time complexity on this thing. And we're going to get the same time complexity with a queue-based solution. So basically what we do is each time we drop into another recursive loop, we increase the thing we're building. So I call this the building variable. Whoops, the building variable here. And then I accumulate in a set the used indices. So this was an attempt to optimize a little bit, but let's convert it to a queue-based solution and see how it goes. So the first thing I'm going to do is slightly odd, which is I'm going to define my stack frame, and I just find that this keeps me a little bit more sane, especially when I'm converting, because I'm basically just copying what were previously named variables. So that's cool. And now, this first call here, where I kick off the permutation, this is actually going to be my first stack frame. So let first frame, which is a frame, equal, and the building thing is going to be, I'm just going to grab these two things because these are great, exactly as they are. And while I'm here, since I've eliminated the result, I'm going to create a new one, which is basically just an empty array of integer arrays. So the first frame looks like that. And now I'm going to define my queue, which is, it just has the first frame in it. And now I'm going to start cycling around the queue and pulling off the first one until the queue is empty, and then we're done. So while the queue is not empty, and now we're going to pull off the frame, the first frame. Let frame equals queue remove first. So we're reducing the size of the queue here. So this is what I'll check later, as always, just to make sure that I'm actually reducing the size of the queue as I go so I don't run forever. Now, the first thing that I'm going to do is straight from here. I'm actually going to take this entire solution and just copy it out because I think this is like the easiest way to go. And I'm going to remove this recursively called function entirely. So this is like my base case here. Even though we're going recursively, basically we don't generate any more frames as we go. So if num's count equals frame used count, then we just append to the frame. So this actually is fine. And whoops. The same thing here. And the same thing here. So this is all fine, and then we can't call the recursive function. We have to build a new frame. So we'll call this next frame, which is a frame. I don't know that we need that. Actually, let's leave that off. So this is equal to, this is exactly these two parameters. And now we add it to the frame. And we're done converting to a recursive solution. Normally I would check this over and read everything, but for one thing, I've done this before, and for another thing, it's not that interesting to watch. But go through line by line and check every single thing if you're at an interview, no matter what. Let's run it, see how it goes. So it runs, it passes all the tests, it's wonderful. And on LeetCode, it turns out it's actually a few milliseconds faster than the non-recursive solution. Not sure why that is exactly, but in any case, it's not bad. Thanks for watching. Thanks for coming with me on this code journey.